Hello, this is Miss Goodwin. Today we're finishing objective 4.1, right triangle trigonometry. The objective is that we can solve for missing measurements of right triangles using trigonometric ratios with Pythagorean theorem. Now we are going to be looking at inverse trigonometry, which is how we are going to solve for angles. So we left off in the last video looking at some of the calculator functions. Now we're going to look at some of the inverses. So before we use trigonometry to solve for sides, now what do we do if we want the angle? So we have to do the opposites. So remember, if we want to cancel something out, we have to do the opposite action or the inverse action. So what is the opposite? So here we have sine of some angle equals 2/5. So we want to know what is the opposite of sine. Now, it is called arc sine or sine inverse. So in the calculators, we do sine inverse like so. And we're going to take the sine inverse of both sides now. Again, this is not multiplication. This is not multiplying by sine inverse. That doesn't make sense. It's a machine that's undoing the other machine. Now, the sine inverse cancels out sine, so we are left with our angle. And then on the other side, we have sine inverse of 2/5. Which, if we plug that into a calculator, that is about 23.6 degrees. Okay, and if you're getting something else, make sure your calculator is in degree mode. Okay. So we have three different inverse trig functions that we're going to learn. Our first one that we've already seen is going to be the inverse of sine. Now this is called arc sine or just sine inverse, which is written in the calculator as sine to the -1. And like with our regular trig functions, it is still using opposite over hypotenuse. So both arc sine and sine inverse of opposite over hypotenuse mean the same thing, just different calculators have it portrayed different ways. The physical calculators use this sine inverse notation, but Desmos uses the arc sine notation. The next function is the inverse function of cosine. And as you could probably guess, that is arc cosine or cosine inverse. And like you could probably predict, it is still using the adjacent over the hypotenuse ratio. And the last angle is tangent, or the last function is tangent, and we are taking the inverse of that, which is called predictably arctan or tangent inverse. And this uses the opposite over the adjacent side ratios. Okay, and those are our three inverse functions. Each box is two different forms of the same one. So we're going to be using these three functions to solve for the angles. So as we see in this example over here, we are looking for x, which is the angle. Okay, we do have, let's label our sides real quick. This is our hypotenuse, this is our adjacent, and this is our opposite. So as we can see, we have our opposite and adjacent. So we are going to be using arctangent. So the angle will equal the arctangent or tangent inverse of opposite over adjacent. So that is equal to the tangent inverse of 44/54. And then we could plug that right into a calculator. That will give us about 39.2 degrees. That is all you gotta do. Now, a refresher, to do these in a calculator, first you need to hit the second key highlighted here in green. Then you're going to select which one of the trig functions you want the inverse of, which I've highlighted here in yellow. So first hit second key, second select trig you want inverse of. Then 3, write the ratio. And then you will get your angle, which is about 39.2 degrees in this case. Let's look at another example. This is our reference angle right here. Label all our sides. This is our hypotenuse. This is our adjacent because it's next to the angle. And this is our opposite. So once again, we are looking for our angle. And we have our opposite and our adjacent. So let's plug them in. Remember, our angle will equal the arctangent of opposite over the adjacent, so the length of those two sides. So our angle equals the tangent inverse of 15 as our opposite over 25, which is our adjacent. Plug that into a calculator, and the decimal where the angle is going to be equal to about 31.0 degrees. And that is how we do our inverse functions. Now let's look at some application problems. Or not some application problems. Let's put this all together. Now, I want you to solve for every missing part of the triangle. So notice, we have this angle here is x. We aren't given a value for this angle, and we don't know what this side is. So there's at least 3 parts we have to find. The first thing I want you to look for is the reference angle. Okay, so in this case, you could pick either one. I'm going to go start with the x. Sorry, my dog is being a little needy right now. So using this angle here, I'm going to label the sides. This will be our hypotenuse because it's across from our right angle. This is our adjacent, and this is our opposite. So we are given the opposite and the hypotenuse, which means we are going to be using the sine inverse. So our angle x will be equal to the sine inverse of our opposite, which is 4.4, divided by our hypotenuse, which is 7.1. And that will give us about 38.3 degrees. Okay. Now we're going to find our third angle. And you can use trig again, but you don't have to. Recall the angle sum theorem. So we can use trig or angle sum. I think that one's a little easier because all you got to do is 180 minus 90 for our right angle minus our reference angle of 38.3 degrees. And these will give you the third angle of 51.7 degrees. Okay, we found two of the pieces. Now we could find the third. And there are two ways we can do this. We can either use Pythagorean theorem, or we can use trig. And you can pick which one you want to use. I'm going to start with the Pythagorean theorem, which, remember, a squared plus b squared equals c squared. Hypotenuse is always c. In the notes, I picked 4.4 for a, and the blank side is b. So let's plug those in. We get 4.4 squared plus b squared equals 7.1 squared. 4.4 squared is 19.36. B squared is b squared. 7.1 squared is 50.41. Subtract 19.36. We get b squared equals 31.05. Take the square root of both sides. We get b equals 5.6. Okay? Now to do it the other way with trig, I'm going to stick with x being our reference angle. So our angle will equal 38.3. We are looking for adjacent. And we were given the hypotenuse. So those mean you're going to use cosine. So cosine of our angle equals adjacent over hypotenuse. That means cosine of 38.3 equals x over 7.1. Let's multiply both sides by 7.1. So we get 7.1 times cosine of 38.3 equals x. Plug that all in, we get 5.6 for our angle, which I actually should have labeled as B, but it's fine. But as we can see, we got the same value either way, so you can pick which one you find easier. Now, I'll go ahead and give this one a try. And I'm going to reveal the answers in 3, 2, 1. Ta-da! So to find our reference angle, I used the arcsine function because we were given the opposite in the hypotenuse. And that gave me an angle of 38.1 degrees for our reference angle. Then I used angle sum theorem to solve for our third angle. So 180 minus 90 minus 38.1. That gave me an angle of 51.9 degrees. Then I showed both methods to find our third side. The left side I used Pythagorean theorem, and the right side I used cosine function. Okay. Now I have one more example on the next page, so let's go. And this is a word problem. So Amira leans a 16-foot ladder against a wall so that it forms an angle of 66 degrees with the ground. Let's draw that out here. So we have some wall here, and we have our ground. I'm going to just assume this is a right angle because if your wall is leaning, you might want to get that looked at. We are told that there is a ladder here that is 16 feet, and it forms an angle of 66 degrees with the ground. So this angle here is 66 degrees. We want to know what the horizontal distance between the base of the ladder and the bottom of the wall is. So that's from here to here. That is our unknown. And we want to round our answer to the nearest hundredth of a foot if necessary. So let's take a look at our information. The angle of 66 degrees is our reference angle. This will be our hypotenuse. This side down here is our adjacent. And the wall will be our opposite. I see we are given the angle and the hypotenuse. We are looking for the adjacent. Adjacent hypotenuse mean cosine. And we're going to use regular cosine because we are looking for the side, not the angle. We are given the angle. So cosine of our angle equals the length of the adjacent over the length of the hypotenuse. Let's plug everything in. We get cosine of 66 degrees equals the adjacent, which is x, divided by the hypotenuse, which is 16. Multiply both sides by 16. We get 16 times cosine of 66 degrees equals our x. And 16 times, I'm going to rewrite that like this. 16 times cosine of 66 is going to give you 6.51 feet for x. So this piece of ground between the ladder and the wall is 6.51 feet. We are done. And you have done all 4 levels of a trigonometry of this objective. So please finish the notes, look back on anything if you're stuck on something. And if you have any questions, let me know. Go ahead, work on the summary on the next page. And I'll see you guys later. Bye!